We tend to think of hot sauce as a simple, everyday condiment, but a single drop of this liquid carries enough chemical payload to completely hijack a mammalian nervous system. This is a verbatim transcript of a person eating a hot pepper. Heat, heat, oh heat, 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 whoa, oh heat. To an observer, a 40-word block of frantic, repetitive stuttering suggests a software glitch or a total cognitive collapse. This text acts as a high-fidelity physiological lock of a human nervous system under siege. The chemical compounds in the pepper effectively seize control of the body's output, narrowing human expression down to a tight, primal roop. The ambush starts instantly. In a fraction of a second, the mouth registers the impact. Heat, heat, oh heat. Capsaicin binds directly to protein sensors on nerve endings called TRPV1 receptors. These typically detect actual physical heat. Once activated, they send a blaring, maximum volume signal straight up the spinal cord. The brain receives data that the mouth is burning. The brain processes this data as a genuine threat to survival, forcing an immediate, urgent reaction to the perceived damage. This panic explains the densest, most chaotic section of the log, a relentless volley of the word heat over and over. The body instantly enters a fight or flight state. The heart rate spikes and sweat glands open up to combat a thermal threat that doesn't actually exist. The brain must triage its limited energy to handle this massive influx of threat data. Power drains away from the frontal lobe, the region responsible for complex thought and vocabulary, and floods into the primitive centers of the brainstem. With the language center starved of resources, vocabulary collapses. The subject is only capable of articulating the single most urgent data point, the heat. Even the sudden ooh in the middle of a transcript is an involuntary exhaust valve, a physical release of tension as the sensory overload peaks. This stuttering is the sound of a biological operating system crashing under the weight of too much information. Right at the peak of this crash, the text takes an unexpected turn. Fragments of social decorum start to emerge. Think, okay, hey, okay. It seems counterintuitive for a nervous system in the middle of a perceived life threat to pause and attempt to be polite. This chart shows internal countermeasures. To survive, the brain floods the system with endorphins and dopamine, shown in blue. These painkillers mask the pain, creating a sudden high, allowing fragmented attempts to regain social order. These flashes of politeness are the outward symptoms of a brain self-medicating, using a narcotic illusion to bridge the gap between the pain and reality. Eventually, the biological fire starts to burn out, leading to the final fragments of the log. Thank you. There we go. Heat. Heat are you. The spikes of adrenaline and endorphins finally recede. The subject is left exhausted, but the perceived threat has passed. Knowing that this experience triggers a literal trauma response in the brain, it's worth asking why we actively seek out this level of sensory overload. Extreme spice acts as a controlled simulation of a high-priority threat. It forces a total system override, drowning out the background noise of abstract thought with a single, undeniable physical sensation. When the chemical fire finally fades, the brain returns to its baseline. The contrast between the intense pain and the sudden quiet leaves the subject focused entirely on the immediate sensory present.